I'm Kevin Renaud, Vice President of Business Development at Peerless. And with me on the screen, you'll see Charlie Hathaway, also at Peerless, and Nick Howard of Oliver Valves.
Good morning.
We are super excited to bring Nick in from Oliver to discuss the future of valves with an emphasis on hydrogen and carbon capture. Peerless has proudly served as Oliver Valves' exclusive channel partner in Northeast US since 2008. Just first, a little bit about us. We're a trusted 110-year-old provider of process components, helping diverse and skilled customers tackle very complex projects and industry challenges with an attention to safety, detail, efficiency, and reliability. We operate mainly under 3 silos. We have our high temp fabrication division.
Kevin,
what?
I don't believe you're sharing your screen yet.
Rookie mistake. How are we doing there?
That's perfect.
Perfect.
All right. Once again, we operate under 3 silos. High temp fabrication, where we machine scientific surfaces for laboratory and medical applications, electrical insulators, refractory stuff. We basically machine items that other machine shops typically would not want any part of, non-metallic. Then our process group, this team serves a diverse range of industries, chemical, pharmaceutical, power, food, manufacturing, and universities, government sectors. And finally, our Procore segment. And 85% of the people in the room today would fall under this group of our customers, OEM customers, custom equipment engineers, rotating equipment, skid builders, EPC firms, and CapEx projects. So how Procore delivers value? We have an extensive experience servicing the OEM, rotating equipment, and energy markets. We have dedicated in-house application engineers and project management teams. We have a deep understanding of project timelines and delivery schedules. We know that's important, getting projects in, getting projects out. And we offer a unique combination of technical expertise, industry insight, and a collaborative approach to ensure project success. Of course, no project is successful without the documentation. We believe our competitors hate it, so we choose to embrace it. And when additional resources are needed, we have a wide group of experts that we can rely on across a wide array of process components, whether it's valves, loading arms, instrumentation, lined product, flow. We had this gentleman in from Steve Munn from PV Engineering, who did a great webinar with us on CRN and demystifying the whole Canadian registration process. So we've got a lot of people we rely on. That's really just a basic overview of Peerless. Before I hand it over to Nick Howard, Charlie is going to just cover some housekeeping. Thanks again for joining us, and talk to you at the end of the webinar.
Thank you very much, Kevin. So just real quick, the main housekeeping item I would like to talk about are questions. We want to make this presentation as beneficial as possible for everyone here involved, so we greatly encourage questions throughout it, whether you would like a topic expanded on a little bit more, or have a specific application question, please do not hesitate to ask. There are going to be a couple different ways you can ask those questions. The first is by clicking the chat icon on the toolbar up top. The chat window should appear to the right if it's not there already. You could simply drop your question in there. I will be monitoring this, and once an opportunity presents itself, I will then ask your question to Nick. Additionally, you can use the raise hand button, which is also up in that toolbar. Once the opportunity again allows itself, I will then give you the power to unmute yourself. Once I do that, your mute button should turn from gray to black, and then you can unmute yourself to ask your question directly to Nick. If you do not get a chance to ask your question during the presentation, or think of a question you would have liked to ask, don't worry, there will be an opportunity at the very end for any additional questions. Now, I'll turn it over to Nick and we can get started. Thank you again for joining us.
Well, thank you very much, Kevin, David, and Charlie, and thank you for the warm welcome. It's a great pleasure to be able to talk to you today about a topic I'm very passionate about. So a big thank you to the Peerless team for giving me this opportunity. And thank you for inviting me back. This is the second webinar that we've done in collaboration with Peerless. And it says something when you're asked back. Not sure exactly what it says, but it definitely says something. And So I hope you find the next couple of slides very interesting and informative. And as Charlie says, if there's any questions or things that you want to elaborate, you want me to elaborate on further, please let me know. I'll do my best to cover that. So the topics I'm going to cover today, we're going to firstly just have a quick overview of the global challenge that's certainly ever present, qualification standards for hydrogen, what we're seeing in the market sector, who's adopting what, and how that sort of fits in with Oliver's gold standard. And I'll explain what the gold standard is. Then we'll talk about a couple of case studies that we've been really fortunate to work on. One in carbon capture, both topside and subsea, as well as some hydrogen power systems, the hydrogen transportation market, and then some real out there specialist stuff with hydrogen subsea developments. And then what I'll finish off with really is some of the developments we've been doing within our in-house R&D facility, from both pipeline valves for hydrogen and how we prove and demonstrate to end users the suitability and reliability. So the global challenge, well, I don't want this to have any sort of political angle. I've taken this extract from the recent COP29 summit that was held in Baku in Azerbaijan. And from the United Nations Secretary, I thought this was a really powerful message, and that message being that the efforts to limit the global temperature of 1.5 degrees, depending on where you look, really, and which articles you read, a lot of places say we have already reached 1.5, which was part of the 2020 Paris Agreement. But really, the message I wanted to get over here is this is happening now. This is within our lifetimes. This isn't something for the next generations to develop. This is very much probably within our career timeframes. And really, it makes you stop and think, what will future energy supply look like? And certainly what I've learned in the last 2 or 3 years is there's definitely not a single answer. There's not a single silver bullet which corrects all the challenges that we've got. And this infographic really gives a good indication of the various green applications. This was actually put together by our marketing team to show the different areas that Oliver's can support within the green energy sector. But what I really like about it, and what I want to use it for today, is just to showcase those different applications, whether it be hydrogen transportation through pipelines, the instrumentation that's needed with steam methane reformers, or even small modular reactors from a nuclear and pink hydrogen environment, right the way through to subsea storage, whether that be hydrogen storage, which we'll talk about later, or carbon capture, where industries are looking to permanently store carbon dioxide in depleted oil wells. But for all of these combined, they're all really exciting opportunities, and that's really just the pinnacle of it, because we're really just looking at it from a valve application point of view. But they all come with their own unique challenges. The challenges associated with subsea valve work compared to something that's in a small modular reactor, are completely chalk and cheese, really. But one of the advantages that Oliver has is because we can adapt our technologies, we can do a lot of knowledge transfer, a lot of technology transfer. So if we start really with the standards, and there are a lot of hydrogen standards, and probably the one that we see most companies and end users adopting are ones that have taken over from the oil and gas sector, similarly like the ISO 15848-1 for fugitive emissions. We see a lot of end users adopting this standard, but it only really, for us, encapsulates the needs of one element of a valve. API 6D Annex M has recently been released, and I was very fortunate to sit on the committee that decided what was going to be in the contents. My own opinion, I think it's got some very good features, such as the SLH specification for hydrogen section, which actually determines the level of testing and qualifications needed depending on the hydrogen application, which I think is a really good feature. It doesn't, however, cover the needs for instrumentation valves, such as needle valves. And to be quite honest, I think it's quite early in its infancy. It's very similar to the requirements of 6D. But that's all for good reason. I envisage that it's going to develop as the market develops. And then at the opposite end of the scale is the transportation for hydrogen fuel stations, the ISO 19880 qualification, which really is an established spec. And we'll talk about this in a little more detail further on. But for Oliver's, we sort of wanted to write our own standard. We're very fortunate that we look across different valve markets, whether it be subsea, pipeline, and instrumentation. And we've seen how those specifications and qualifications have developed over the years as testing methods have improved, data acquisition methods have improved, and where end users have wanted manufacturers to demonstrate more in-service simulated tests. So we thought, well, what would a hydrogen standard look like in the future? What are the certain elements within it that operators and end users are going to really want to see to be able to showcase or prove product performance? So we've added things like fugitive emissions, which makes sense. You know, fugitive emissions are often tested with helium, and helium behaves similarly to hydrogen, not exactly the same, but similarly. Helium seat tests were certainly high up on the agenda. The valves that we sell are all isolation valves, so we wanted to prove that our products could seal with a gas that behaves similarly to hydrogen. We test at minimum and maximum rated temperatures because we want to be able to demonstrate that the product is suitable for all its extremes within the data sheet or requirements. And we've been able to test all these different parameters using helium in our in-house R&D facility. And then we've actually gone a step further. We then got this verified to our own standard with TÜV in Germany using 99% hydrogen. And we're very proud of the fact that we were the first valve manufacturer that TÜV issued a certificate for hydrogen compliance. But the real magic is that's allowed us to be able to compare directly the performance of a product when tested with helium compared to the effects when tested with hydrogen. And that's allowed us then to benchmark a whole range of products to be able to see the difference. And there is actually quite a difference between the two. So this really is the base level set of qualifications that we introduce for all our hydrogen products. So I'd like to talk a little bit about a case study. We were very fortunate to be involved with a carbon capture project for the Asia Pacific region. It's said to be one of the biggest carbon capture projects around at the moment, and we were fortunate to offer a range of both instrumentation and pipeline products. The project aims to capture 3.3 megatons a year of carbon dioxide, which is about equivalent to taking 1 million cars off the road for a year, or a third of the cars off the road in New York State, just to give you a bit of an idea. But I suppose the sobering thought really is this is the world's biggest project at the moment for carbon capture, yet the world would need another 12,000 of these projects to be able to capture current CO2 emissions. It's expected to go live very shortly, and we've been very fortunate to be able to go through the detailed qualifications within our in-house R&D department. So what do the products look like? Well, they use our tried and trusted double block and bleed concept, which you may have seen right at the beginning of this presentation. Very cost effective. The materials of construction we used were stainless steel, which is very well suited to the slight acidic nature of carbon dioxide. Size-wise, we went from instrumentation, small needle valves, right the way up to pipeline products, 2 and 3 inch, and up to 1500 class, over a very wide temperature range. So down to about -150 Fahrenheit, up to 365 degrees Fahrenheit, which made sealing abilities pretty difficult over that temperature range. We justified the valve's performance over a detailed qualification that included 200 cycles, that incorporated maximum pressures or working pressures, both at minimum and maximum temperature. Seals we used were all qualified to Norsoc M710, and the products that we used are very cost sensitive. One of the issues or challenges with the carbon capture market is there's no real monetary incentive for this sort of technology at the moment. And as a result of that, it's a very cost-sensitive market. And the product that I've shown there on the right is one of our 2-piece floating ball double block and bleed valves, but it's perfectly suited to this sort of application. It's very simple, reliable, cost-effective, yet we've got 30 years now of field experience to be able to back it up. So it really is well suited to this cost-sensitive market. Continuing on with the carbon dioxide theme, and through our subsea division, Oliver Valve Tech, we've worked on a number of pilot schemes and trial projects for carbon dioxide storage subsea. Now, whether that's for sequestration into depleted oil wells, of which we're blessed with quite a few depleted oil wells in and around the UK and Europe, or for enhanced oil recovery, because we're also blessed with a lot of empty oil and gas wells around the UK. Again, a very cost-sensitive market, and the product that we supplied on these was our rotary disc valve, which I've shown here. Now, a rotary disc offers quite a few advantages that are suited to this sort of application. It's compact, simple quarter-turn operation, but yet it gives the performance and reliability of a through a slab gate valve. Tested to about 2,000 cycles, full metal-to-metal sealing and gas tight, right up to 15,000 psi working pressures, down to depths of 10,000 feet. But again, very suited to this application, and we're hoping to see a lot of growth in this area in the future. So there's lots of talk in the media about energy security and flexible energy solutions, and one really flexible energy solution is the aeroderivative generators. We've worked with a company that provides this sort of power system that can produce up to 590 megawatts. It's pretty equivalent to about a small town's worth of houses and infrastructure. And the fuels that are used on this sort of system range from sort of natural gas, kerosene, but they wanted to add a green fuel into their portfolio but that meant a change of infrastructure and a change of products within the skid system. So we helped to work with them to produce small bore quarter turn ball valves where we could demonstrate ultra reliability for this very critical application. So we worked closely with the end user, not only to develop the product, but also the qualification testing that proved the product performance. As I said, this is a small bore vent fuel line, and had to operate extremely quickly. But with our advanced data acquisition techniques, we could actually demonstrate the speed of sealing or communication. Now, that's actually the bit that the end user was interested in, not necessarily the speed of the actuator, but how quickly the valve could seal or communicate through the inlet and outlet ports. Now, we could demonstrate that not only at ambient temperature, at maximum and minimum temperatures of -40 degrees Fahrenheit, right the way up to sort of 390 degrees Fahrenheit, but also a combination of the two. And one of the specialist tests we did involved the test media and the valve being at opposite ends of the temperature range, and then seeing the effects of the operation and the speed of operation to really prove product performance. Working pressures up to about 5,000 psi, and the whole system was very size sensitive. These are built into quite compact skid units, so we were very conscious of the overall envelope of the product. And like I said, we worked closely with the end user to design a specific, or to write a specific qualification test that incorporated thousands of cycles, at the end of which the valve still needed to be zero leakage with helium and within leakage rate BH from a fugitive emissions project point of view. Really interesting project, and one that I think this sort of technology can be used in several different applications in the future. So expanding market that we're seeing with the transportation really is to do with high energy transport systems such as trucks or heavy goods vehicles. Recognize that it's a big challenge to move away from traditional fossil fuels. This probably explains why the market for valves for transportation really is expanding at a great rate. Now, the particular valves that we're developing, again, small bore ball valves, these are actually used within the dispenser system to isolate the fuel. But because the fuel travels through the valves, an increase in flow is a direct advantage for the end user because it reduces fill times, which in essence gives a big safety advantage. And the pressures we're seeing, the working pressures, are on the rise. So it used to be about 5,000 psi, but now 10,000 and even 15,000 psi applications are what the customers are after. And they're all qualified to this existing standard 19880. Now, that standard calls for 100,000 operations at working pressure. Now, typically for Oliver's, a high performance valve probably do about 2,000 cycles within its qualification. So this one, 50 times more, add it with 1,000 cycles at maximum temperature and 1,000 at minimum, really meant we had to take a different approach. So with the help of our mechatronics team, we built a bespoke test skid that allowed us to test 4 valves in parallel 24 hours a day. Now, what that allowed us to do was to very quickly test out different sealing mechanisms different materials, different configurations. But like with our gold standard, we wanted to prove these out individually. So the valve has a secondary stem seal arrangement, but we've proved each stem seal arrangement independently throughout the entire 102,000 cycles. Now, the spec says you can actually change the seals out every 16,000, but we wanted to set the bar pretty high, and we've been able to do that right the way through the 100,000 cycles. But again, it was a different approach. We got a little bit blasé with the number of cycles. Once you get sort of about 60,000, we knew we were onto a winner. So really good products, and we've been able to very quickly develop 3 sizes over a number of pressure ratings. They can be supplies in a different, all sorts of different end configurations, but I see this particular market as almost, from a development point of view, being almost never ending. I think the customers are going to want higher pressures, larger bore sizes that meet this quite rigorous test regime. As I mentioned earlier, subsea hydrogen storage really is a combination of high technologies. I think it's a brilliant concept where the excess energy from wind farms is used to generate hydrogen. So when the wind's blowing and there's not the demand on the electricity, seawater is converted to hydrogen and stored in hydrogen tanks, enormous, great big hydrogen tanks subsea. Then when the demand for energy increases, the hydrogen can be either used as a fuel stock or to generate electricity. And we've been very fortunate to work on a project where they needed subsea valves for hydrogen application. And austenitic stainless steel being the choice of material for hydrogen really does go against the grain when it comes to subsea valves. Subsea valves are often riddled with duplexes, super duplexes and inconels. So again, it was an out-of-the-box style thinking to be able to match the performance of existing subsea valves, but made out of hydrogen-friendly material, or hydrogen-suitable material. We worked very closely with the end user as well to come up with a qualification that would really be suited for hydrogen. So we took, again, the elements that are well known in the industry for subsea and combined those with what we'd learned from a hydrogen perspective. So some of the further developments we've been working on, and this really carries on from our first webinar, where we've developed some high performance metal seated pipeline valves. Now, when we first developed the hydrogen valves, we wanted to prove the performance from a metal seated point of view. With having a lot of experience in gate valves and subsea zero leakage gate valves, we were able to take that technology and incorporate it into a pipeline valve. And we've been able to produce zero leakage when tested with helium through now over 1,200 cycles. And this is fully compliant with hydrogen from a seal and material point of view. And then we took it a stage further to do the endurance class CO2 for fugitive emissions. And that's over a temperature range of about 3 degrees Fahrenheit, right the way up to 250 degrees. Other developments we've been working on are a low-cost fugitive emissions needle valve, but rated to fugitive emissions level AH. We've seen a lot of interest from this from panel manufacturers electrolyzer companies that really want a small, compact, but high performance valve with almost zero emissions. I know it's very difficult to quantify zero fugitive emissions, but certainly the AH part of ISO 15848 gets very close to that. So very shortly, you'll see some more information on that in the media. That draws me to a conclusion. So thank you very much for your attention, and I'll be more than happy to answer any questions should you have any. Thank you.
Thanks, Nick. I'm not seeing any questions coming in, but if you do have those questions, either raise your hand or drop them in the chat. We'll be sure to get those answered. Not seeing anything pop up or any hands being raised. So I think that will conclude. Oh, we do have a question from a Jackie. Just give me 1 second and let me allow your mic. And now you should be able to unmute yourself to ask your question.
Sorry, Charlie. Nick, first, I want to thank you so very much for this presentation. It was really, really inspiring. And I just have another question. I think this new technology is going to be amazing. What is Oliver, like, do you guys have any plans for like the larger countries that have a lot less regulations? You know, countries like China and India that are building coal plants and things like that. Obviously leading to more devastation to the planet. Does Oliver have any plans on maybe offering this type of newer technology to them as well, as far as you know, trying to make the atmosphere and the world a cleaner, safer, healthier place?
Yes, certainly. Yeah. Oliver's is very much a global company. And I think to answer your question, that for certainly some of those developing nations that still use a high percentage of fossil fuels, the carbon capture technology that is rapidly expanding within the UK is perfectly suited to that sort of environment, because in effect, I don't know, a lot of people might disagree with it, you can actually carry on using fossil fuels so long as you capture the emissions and still be striving towards net zero. So that's one of the reasons why I'm quite passionate about the carbon capture technology, because that allows a transition for all nations to be able to go from fossil fuels into green energy if they haven't got the infrastructure to go directly to hydrogen and electrolyzers. Does that answer your question?
I'm sorry, my mic was muted again. Yes, thank you for that. And just hopefully going forward, as the technology advances and things like that, hopefully they will get on board, because I'm sure that, you know, for everybody involved, because we all use fossil fuels and things like that, that maybe they would be more inclined to, you know, be more receptive to taking on this new technology, and also helping, you know, keep the environment a lot cleaner for everybody. So
Yeah. Thank you.
Perfect. Thank you, Jackie. And then we do have another question coming in from Justin. You should be able to unmute yourself now to ask your question.
All right, thank you. Question I have for you is, what's the highest temperature your metal seats can go up to? on your hydrogen valves?
Good question. For the hydrogen valves at the moment, it's about 320 degrees Celsius. So whatever that is in Fahrenheit. Yeah, about 320 degrees Celsius at the moment. For non-hydrogen applications, we can go up to about 500 degrees Celsius.
For that 320 Celsius, what type of valve body would you be using for say a ball or gate, or what is that applying to for you?
That'd probably be either carbon steel or stainless steel body. So either a high yield carbon steel, or if it's for a hydrogen one, would be stainless steel.
Would it be possible after this meeting here if you could send me a link to the brochure for that particular product?
Yeah, sure.
I appreciate that. Thank you.
Perfect. Thank you very much, Justin.
Anything else, Charlie?
There is nothing popping up as of right now.
All right. Well, Nick, certainly thank you very much for doing this for us today and for our customers. And I think everyone in attendance knows how to get a hold of us. If you would like any additional information, we do appreciate your support and look forward to working on some exciting new projects ahead with you. Thank you very much.
Brilliant. Thank you.
Thank you.
Thank you for listening.